Yeah, good morning, everyone. Good to have you today. So today we'll be talking about AWS private networking, VPC interface endpoints. So you can remember that last week we talked about VPC gateway endpoints, but this morning we'll be talking about VPC interface endpoints. So this is about me, and what we'll be discussing today is actually why are we using interface endpoints? What's interface endpoint itself? And we are going to try some use cases as regards EC2 Instance Connect using interface endpoint and as well SQS. So we're going to try that two use case regarding interface endpoint. Now let's get started. So why are we using interface endpoints? So number one is seamless communication. So the last week we talked about gateway endpoint. Gateway endpoint only works for two AWS services, S3 bucket and DynamoDB. But what about KMS, key management service, simple email service, and all other services aside from these two? They are going to use interface endpoints. So instead of you going through the internet gateway or the NAT gateway to access those services, because those services are actually a public service, but you can't just go over the internet to be able to access them. So you need to go through internally seamless communication through the AWS private network. So that's why the interface endpoint comes. So we're talking about your KMS, your CloudWatch, your Lambda, all of your services, you can easily access them through interface endpoints. Please, if just try and understand everything I'm saying. Like, I want you to understand it. So if you are at the point that you are not getting it, just try to call my attention. So instead of you transversing, all the services are available over HTTPS, and there are services available over the internet. But why will I be in AWS? I'll still need to go to internet before reaching those services. First of all, it's not seamless in that way. So that's why we have the interface endpoint. So the traffic will just move directly from your VPC and straight to where the services are deployed. So if you are running simple notification service, simple queue service, CloudWatch, Lambda, talk of any services, you need to use interface endpoints. So enhanced security is within the AWS private network. So it's not something that is exposed. Optimized performance. So we all agree that the latency for you to go to the internet is very high compared to when it's not going through the internet. It's going through the dedicated in AWS network. So instead of you now transversing, maybe having some latency, trying to reach your Lambda or trying to reach your simple queue service and all of those services trying to go over the internet. So you need to attach a public IP, you need to attach an elastic IP, you need to go to your route table, put in all those things. And at the end of the day, this guy is cost efficient. So you know the cost you are going to associate to your elastic IP, the cost you are going to associate to your NAT gateway, the cost you are going to associate to your internet gateway. So those costs, you've already depreciated them by using the interface endpoint. Because at the end of the day, it just only speaks to what you need. So that brings us to the simplified architecture. You speak to what you need directly from your AWS account. So you don't need to start going to the internet before getting to your Lambda or before getting to your CloudWatch and all of that. Last week we tried using S3 bucket. We tried from a private server, from a private subnet, and we're able to access it. So today we'll be looking at the interface endpoints. So this is how it works. So you can see that on this is a typical VPC. This is an interface endpoint. So this guy is on a private subnet. And the interface endpoint uses what we call the private link. Private link, just see it as a private link from the name. Just a dedicated link that can extend from your VPC to AWS network. So this kind of link, you don't need to go to the internet to access CloudWatch, Aurora, S3. No, another thing, S3 has two types. S3 can be an interface endpoint and it can also be a gateway endpoint. So the guy is a very lucky guy. So this guy, you can use it to access KMS, Aurora, Kinesis, all services, most services, you can use the interface endpoint. So how does the interface endpoint actually works? It works by creating an ENI. What does an ENI means? Elastic Network Interface. So it's going to automatically, once you create an endpoint, it creates an ENI. This is the ENI, Elastic Network Interface, just like a NIP card, an ENI, like an interface card. It's going to attach it to that subnet. So that's a NIC, that's going to be your access point to the interface endpoint that you are going. So with that NIC, it's now going to be able to get to your environment. So this is how the traffic works. From your EC2 instance, it gets to the NIC. From the NIC, it gets to the interface endpoint. From the interface endpoint, it goes to the private link and goes to that services that you created. Now, another interesting thing is that this interface endpoint doesn't use routing. The last time we are talking about routing, we need to create a route table. It's going to create a prefix list. If you remember our last session, that the gateway endpoint, you need a prefix list which contains a set of public IPs that will be added to the route table. But in this scenario, we are not using that. What this guy is using is DNS, domain name service, domain name system. So what this guy is going to do is somebody said he's not able to join. This thing is free. Everybody should be able to join. So this guy uses DNS. So now there's two things in AWS. We have regional DNS and we have zonal DNS. Regional DNS is, we have different regions. EU West 1, EU West 2, US Central 1, US East 1. Those guys are region. But zonal is the availability zone. US East 1A, US East 1B. So what this guy is going to do, interface endpoint will work at the end of the day is that it's going to create DNS, domain name resolution, for all those endpoints from your VPC, because this guy is already on the AWS network. It will be able to automatically resolve all those endpoint services. So this guy, he doesn't use routing, but it uses DNS. Using the DNS, is going to be able to resolve all those services through the endpoints. All you need is just to attach an ENI. Once it creates an ENI, you will then see the DNS for each of the services for each of the endpoint services you created. You see the DNS for API gateway, for CloudWatch. So through the DNS, it's going to be able to reach them. Now let's move forward. So interface endpoints, I've explained this. It uses an elastic network interface to provide a private connectivity between your VPC and the AWS services. And I've explained the regional and the zonal endpoints as well. So you can use this interface endpoint to access a lot of services. For example, your EC2 Instance Connect. You can remember last weekend, we want to access our private server directly from the AWS console. I showed us the different way we can access the server, the Instance Connect, the serial console, and the SSN. But you can see that the Instance Connect is not coming up because the server doesn't have a public IP. So now today we're going to now do something interesting. So and as well, for the private link, avoid routing the traffic over the internet. So as I've explained, it takes it through that dedicated network of AWS. So it doesn't transverse the traffic to the internet before it gets to all those AWS. And is the costing is per hour, not per minute for your internet gateway and all of that. So it's the processing charge is very, very little. And another thing to note here is that you need to attach a security group to your endpoint, your interface endpoint. The gateway endpoint doesn't have security group. If you remember very well, we didn't do any security group in our last class. So you need to attach a security group to this at this point for this interface endpoint. And this is just the steps to do it. Don't worry, we'll go by the step. I'll share my screen and I will take you through all the steps one after the other. But what are we doing today? This is our use case. This is our use case. So the same Solis company, so they want to enhance their infrastructure security. And what they do is that, what they want is that private SSH access. They want all developers should access the servers through the private servers, the private servers, not via the internet. So they don't want any public IP to be attached to any server. Because if there is no public IP, there is no way we can use PuTTY on or any of these guys to reach it. Do you understand that? So I don't know. Are we together?
Yes, sir.
Yes.
Yeah, we're together.
Okay. So since so the first guideline is that we want private SSH access. That's the first guideline. The second guideline is that they have a distributed the company has a distributed architecture. So they use a distributed messaging service, which is called simple queue service. I mentioned it last week, something like an Africa. You can subscribe to that. So application will be made to the queue. Another application will consume from that queue. So the company also has something like that. So they want to post message, receive message, and all of that. And also the simple email service. They should be able to send email service to their customers via their private network. They don't want any servers to have public IP. So they want all these guys to be done privately. So that brings us to a real use case of the interface endpoints. First of all, we're going to try the EC2 Instance Connect, and also we're going to try the simple service. Create a simple service. We're going to post a message from a server and even confirm can we reach that server. Are we together? So let's so let me share my screen now so that okay AWS sign in. So I'm going to sign into my AWS account now. Let me go to my MFA. Okay, so let's try. I think we use a server in the backend VPC last week. So let's take our VPC. This is our VPC. So I don't know why it's taking time to come up. So what we're trying to do. So let me go back to my slide and show you something. So this is what we want to achieve at the end of the day. So this is just like an architectural overview of what we want to achieve. So this is the backend VPC, and this is the private subnets in the VPC, and this is the ENI that will be created when we use the interface endpoints, and this is going to be the EC2, the SSH user. So we don't want to access the server via the internet. We want to access the server privately. So how do we do that? And the server doesn't have a public IP. So we're going to use what we call the EC2 Instance Connect interface endpoints. And also we want to post a message to our simple queue service. So that's the Amazon simple queue service. So we want to post a message from this private subnet to the Amazon SQS service. So those are the two things we want to achieve. And this is typically this is how the architecture looks exactly. So this is what we want to achieve. So let's go to our backend VPC, private subnet, and let's start. There's so we have, which subnet is this? I think let me change my region. You know, this is US East 1. Let's go to our US West 1. I think that's where we have our resources. So we are trying it out with the backend VPC. Let's see. So this is the backend VPC. As you can see, the backend VPC. This is what we have here is 192.168.0.16, and we're going to use the private subnet of the backend VPC. So let's create a new tab and go to EC2 instance. I hope I've shut down this server since last week. I think, yeah, I did. So this is the backend private server. As you can see, this server, let's go to the networking. This is what we're using. So this private server is in the backend VPC, as you can see, in the private subnet. And yes, so this is what we're going to use to do our lab. So let's try to spin up this server. Let's spin it up. Instance states. Let's bring it up. Let's start it. So we can all agree that this is the backend private subnet that we created at the beginning of our session, series. And this is, so we are trying to access from that architectural diagram. I'm going to share this slide after the session. So from that architectural diagram, so we want this particular service, we want to be able to access it to it, but we don't want to assign a public IP. And as well, we want to post SQS message as well. So once the server is running, is it 100% okay? I think the status check is still initializing. So let the status check get fully approved. So now let me do something. So if you are connecting, you can see it's running. So let's do connect. If I'm connecting, I actually showed us this session yesterday. We have the SH client, that's when we use PuTTY and all of that. But it has to be a public IP and all of that. So you have this session manager, that's another service. It has an agent and all of that. But we're not talking to that one today. Can you see Instance Connect? You can see that instance is not in public subnet, right? No public IPv4 assigned to this guy. So what we're going to do is that we're going to try the alternative, which is called connect using EC2 Instance Connect endpoints. I get my point. So I can do it this way. I can create it this way. I can go to interface endpoints and create it from there. But it's just to show you the variety of ways you can create your interface endpoints. So if I click on connect using interface endpoints, so now select an endpoint. So it brings me back to where I need to create my endpoints. So you need to create an endpoint. So you can create it from here, just like the dialog, create it from here, or you go to your PC, come to the endpoint, create it from here. Let's create an endpoint. So it's going to bring the dialog to create an endpoint. So you can see this is, so now what's new can we call it? Let's call it backend SSH endpoints. Are you getting? So which service are we consuming? We want to consume the EC2 Instance Connect endpoint, right? You know, last week we had to click AWS Service Endpoint. That's what we did last week. But this because we want to use the Instance Connect. So then, which VPC? The backend VPC, right? So that's why I said this guy, you need to give it a kind of security group. You need to reference a security group to it. So you need to create a security group. So you can create a new security group here, or we use the SSH remote because it's SSH. So what the security group you need to create is like the inbound on port 22. That's actually what you need to create. So you need to create an SSH group. So just to allow the SSH command, I get it. So you can choose this existing one, or you create anyone you wish to. You can create. You can just go back and create a security group, or we choose the existing one we have. So let me even do it. Let me create a new security group so that it won't to be very clear. So I told you that security groups works per VPC. So that's another thing you need to know. So you don't make the mistake. So security group works per VPC. Now let's create a new security group for the guy. Create security group. Let's call it instance connect backend SG security group. So I'll just put the same description here with VPC, backend VPC. So we're not allowing all traffic. Let's just do SSH from anywhere, and let's do HTTPS as well. We can. So let's just call it instance connect backend SG. So still that name still works. So let's just put from anywhere as well. Or we can do anyway, or can still make it okay. Let's be security conscious. 192.168.10 .0.0/16. I get to my point. So we can do it just to make sure that okay, we are security conscious. We're not giving a blanket rule. This is actually the CIDR range of this VPC. As I said, 0.0/16. Great. Why is it not creating? What's my mistake? What's my mistake? I need someone to tell me my mistake. Can anyone hear me? Hi guys, are you following? Are you with me?
Yes, we are with you.
So what's my mistake? I made a mistake now. What's my mistake? What's my mistake? I need somebody to say something. What's my mistake? I need a mistake now.
But it has accepted the block now.
No. I made a mistake. You can see that security groups works on the inbound. You only whitelist on the inbound. The outbound, you leave it as planned. So what I did, I went to edit the outbound. I get
Instead
my
of
point.
inbound. Okay.
Instead of inbound.
Okay.
So let me just all traffic. So outbound is always like anyway.
So when you did that, it was not allowing it, right?
Yes, it doesn't align in the first instance. Yes, it didn't. It accepted it. It's actually accepted, but it didn't allow it at the first instance. I clicked. I had to like click it twice before it allowed itself.
Okay.
So what my interest is this inbound, because we explained that security group is stateful, so it only checks the inbound. So the outbound is free. You can once it enters, it has the permissions to go anywhere. So now what we are interested in is actually the inbound. So let me put it here. Custom 192.168.0.16 and HTTPS as well. So that's 168.0.0.16 several. So now, so I click this guy once time and everything is fine. So now let's come to our create endpoints. Let's refresh. So you can see that we have this security group here now. So we just click it. That's what we want. So our subnet, where is our this thing? In the private subnet A. So we click it. So we can choose multiple subnets, but since this is subnet where we have our server, so you can, the subnet works per subnet, the interface endpoint works per subnet. So you can just create it based, you can even do an availability, put one in private subnet A, private subnet B. So it depends on what you want. So let's create the endpoints. So interesting. We successfully create the endpoints. Sorry. So we successfully create the endpoints, right? So what's the next thing we're going to do? So if we create the endpoints and let's see the status is still pending. It's still pending. So once it's fine, so we can then come to here and we create because this server is, you know, the last time we tried to bring up this server is let's see the image running on this server, the IMI. I want to show you the AMI running on it. So the AMI running on it is the Amazon AMI location is Amazon EC2 image. So it's not Ubuntu. So the username is going to be EC2 user. Assuming we're using Ubuntu, it's going to be a different thing. I get my point. So now let's see if it is has been created. It's still pending. Let's wait for it to be created. So do we have any question? Do we all get it to this point? Is there any challenge? I hope you can all see. Can we hear me?
Yeah, sure. There's no challenge. Maybe we'll just quickly reference the diagram again.
Okay, it's interesting. So can you see my screen? So this is the diagram. So this is my EC2 instance. This is the EC2 instance. So this is so once I create the endpoint is going to create an ENI. So once that provisioning is done, you will see the ENI that will be created. So you're going to have an ENI. The ENI will be linked with the interface endpoints. So then I'll be able to connect to the SSH to this server from this guy. I get to my point.
Yes. Okay.
So even despite that, this guy doesn't have a public IP, I still have the access to SSH to the server.
Oh.
So that's what I want to achieve. So so it's trying to provision an ENI. That's what I'm taking a bit of time, but let's wait. So I haven't said that. So this is the first part of the equation. What about the second part? So we want to create a simple queue service. So now let's well, I want us to log into that server first, at least to establish the fact of the first one. But at this point, I think we all understand, right?
Yes, I think for me, I do.
Yes.
Okay. So the second service, if you check the diagram, so this service, it can be simple email service, it can be anything, it can be a lot of different things here. So it can even be a Lambda function, it can be different things, but based on the use case we are working at, so we will try to send a message from simple queue service from our EC2 instance to simple queue service. So that's what we're going to do now. But let's I just want us to try and create a message first and create, but because of time, let me just go here and search. Let's search for SQS simple queue service. So it's taking a lot of time. So this is a simple queue service. So let's create queue. So if we say a queue is just like a message, how would I put it? A queue is just like a distributed message service. Okay, I want to talk to Tokwe. Tokwe, we are in the same, maybe we are in the same class. But I can't talk to Tokwe directly. I need to talk to the teacher. Teacher would have talk to Tokwe. So all of us in the class need to talk to the teacher. So the teacher is just like our queue service. So anything when we're talking about loosely coupled architecture, that's what they use. For example, maybe all these even Twitter, all those streaming apps, they use queue service a lot. But it's a different name in some companies. Some people use Apache Kafka, some people even use Redis and all of that. So it's just like, okay, I'm sending message, but you'll be taking it first and be sending it to the different guys that need it. So that's how queue works. So let's call it our backend queue. Okay, let's call it this morning. Let's call it demo queue. So it's the standard. Let us put it at default. Let's put it at default, just basic. Let's put it at just basic. So we're not treating queue service today, but I just wanted to prove something. So that's why I'm creating it. So this is you see how it actually works. So basic and all of that. That's great. So you can see this is my SQS URL. So if I post a message to this queue service, if I come to send and receive message, I'll be able to, I can send a message here. Maybe I have it, but I can only send a message to a subscriber. But I don't have any subscriber yet. But maybe I want to receive a message. Maybe somebody send a message to this queue. I can come to the send and receive message and pull the message. So that's why you can see subscribe to SNS topic. Maybe I have another application that needs to collect the message from this guy. So I can then have it on my side. But we're not looking at the subscriber part now. We're just looking at the publishing part. So this is the queue URL that we're going to work with. This is SQS URL. So let's check if our endpoint is fine. Yeah, we're good. This guy has been created. So you can see something. You can see that this guy, this is the details. This is the details. We've created it. So you can see the DNS and all of that. And let me show you something. This is the backend SSH endpoint. The Instance Connect has been provided. Now let's come to Elastic Network Interface. Elastic Network Interface. If you see it, let me know. I'm not seeing it though. Let's check here. Let's check here. Should be here. Should be somewhere around here. Network interface. Can you see instance? You can see the second line here. This one is what EC2 Instance Connect endpoints. Are you getting my point? It has been given an IP in the private subnet.
Okay, 46.
Are you getting exactly? So that's why I said Elastic Interface Endpoint works with ENI and its DNS name. So if I come down here, I'll be able to see the details. You can see the VPC. You can see the security group that we attached to it. So this is what is going to use to be able to access the AWS service. You can see all the details. You can actually see all the details here. So this shows us that an ENI has been provisioned for us that we can use to access the service.
Okay.
Okay, so when we created the interface endpoint, it's created the ENI automatically for us.
Exactly, yes, it created it automatically for us. So now let's go to our server. Let's try to log in now. Even though this guy doesn't have a public IP, right? Let's see if we can connect. So you can see that we can use the endpoints that pick it up automatically. So that's the only one we have. So we pick it up, we put the EC2 user. This is like the duration, like the and the username is EC2 user. So let's try if we can connect. Let's see if we can connect. Can we connect or we can't? Let's see. It's looking as if it's going to work. Yeah, we are there.
Yeah.
WD. So you can see that we've been able to log in successfully.
Sure.
So we don't need internet to be able to log in. Exactly. Or maybe you want, so there are some servers that maybe the servers don't even need to speak to internet, or you don't need to do any other thing there and all of that. So you are actually, but you can't ping internet. You can't ping Google because there is no internet gateway. There is no anything. Ping Google.com. But we've achieved our aim. Our aim is to be able to log in, right?
Sure.
Which we've been able to log in. But
Sure.
you can see that we can't reach anything on the internet. But at least we've been able to manage the stress of using keys and all of that. Are you getting my point?
Yes.
So now maybe you have an app, this server that needs to talk to other AWS services that you don't even need internet. There are some connections that you don't even need internet for. Maybe you want to connect to S3 bucket, you want to connect to your simple queue service or simple email service or to a Lambda or to any other AWS service that you don't even need internet at all. That you just want like an end-to-end management service directly on AWS. So automatically you've cut all the costs that can be associated with public IP, elastic IP, NAT gateway, internet gateway, and all of that. I get to my point. So at least we've been able to log in now. Interesting. Now let's look at the other question in our listing. So I think we've been able to at least we've been able to get this done. So we've been able to get the private SSH access done. That's fine. So the second thing is that we want to do the SQS service, the simple queue service. So I've already created a queue. Let me go to the diagram. We've been able to do this, so we can SSH now. So we want to do a queue. So we want to post a message from the EC2 instance to this SQS and see if we are going to get it. So now let's try that one. That's the next thing we're going to try now. So we let's go to the queue. So we've created a queue, right? So and want to send and receive a message. So let's copy the queue URL. This is the queue URL. AWS SQS body. Future newest one. So we can see that it's running a message body, right? So let's but it won't actually work. I think we didn't get the message very well, but it won't actually work because this guy is not connecting to SQS at the moment. I get my point. So what we need to do now is we need to create an interface endpoint for SQS. Let me just you can use the app. I use the app this thing. SQS app. So this is the SQS. So it can come down. Available commands. Create queue. Delete message. We also want to send message. We want to send message. So this is send -message. So these are the available commands. So message. Let me queue SQS send -message. This is how you use Apple. Nobody will start memorizing commands. So can you see? I think I made a mistake. It's supposed to be -q underscore URL. I get it. -message body. So this is what we need. So let me just update it and so these are just the message. So you should be willing to use app commands and all of that. You can start like memorizing commands. It might take a long time. There's a lot of things to memorize actually. So I think I've get the right syntax. -KURL and message body. So let's queue. So let's run our command again. Message body, and the last one is -KURL, right? So let's send it. So if I send it, you will see that it's not working because this particular server doesn't communicate. It doesn't have access to SQS. So that's why we need the interface endpoint to provide something that we can use to be able to reach the interface endpoint. Are we together?
Yes, we are. Yeah.
So we can see that it's not going. Before, it should have thrown me an error command, but you can see that it's not going. So maybe it's likely maybe after the timeout section, it's going to show like, okay, oh, the command is not running and all of that. Like it can't communicate. So that's why you can wait for the timeout period. You can see that it's not reachable. I can't send the message. Assuming this thing is working, we should be able to see a response immediately. So now let's cancel it. Let me just Control C.
But we're expecting it to be reachable since we've created the.
No, we've not created the endpoint for SQS. We've not created the endpoint. We only created the endpoint for EC2 Instance Connect. Yeah. So we need to now create an endpoint for the SQS service. Now, let me now explain something. You know, last week we did something we called IAM role. We have created a role. We attached distinct SQS as S3 access to it the last time. Same thing we're going to do today. So this EC2 server, it already has a IAM role. We just go to the IAM role and update it with SQL full access. But hold on, let's create our interface endpoint first. So let's create endpoints. What's the name of the endpoint? Backend SQS service. So it's an AWS service. What's the service? Let's use SQS, right? So you can see the type SQS is interface endpoint. We click on it. We choose the VPC. I will get to my point.
Yeah,
So
back
these are so we can use, yeah, so we are choosing the subnet. So we can choose two subnets, but
Yeah.
let's just choose the one. Well, let's choose this one
Private.
because we only have one server in that private A. So security group, the same thing. So this guy, this guy is exposed over the internet. But this guy is exposed over the internet. They are public service, and public service is like HTTPS. If you tell this QURL, you can see that it's HTTPS. So it's 443 ports. So that's why when I was creating my security group earlier, I had 443 to it.
Okay.
I just don't want to come back here and see. So that security group that we created earlier will work for this because the security inbound rule allow port 443 as well. The first one we did is for SSH. That's why we're able to SSH directly without using public IP. But this one is HTTPS, SQS. This endpoint is HTTPS, and HTTPS is 443. So that's why we in the security group we need to allow inbound on 443. So we come here, we create the last one we did, which is this. So let's the VPC endpoint policy. So this is like a custom one. You can do custom one, like okay, we only want a particular server or a particular IP to be able to. So that is when you are talking about custom one. But at first, let's just do like a full access. So let's create. So one, it might take time to pen because this guy also is going to create an ENI as well. So before it does that, let's go to our IAM role. This server has an IAM role. The last time, I'm coming. You can see IAM role is backend S3 access. So now this backend S3 access, let's just update the IAM role. So we can so since in IAM role, is more like an authorization. What do you need to talk to? The last class, we want the server to talk to S3. So we give it an S3 access. Now we want the server to talk to SQS as well. So we are going to assign SQS access to it as well. Am I communicating?
Yes, sir.
So this was the last one we did the last time. So the only thing we need to just do is add permission, attack policy, and we'll just come here, SQS full access. And we click it, and we add permission. And we add permission. I get it. So this thing is it's very straightforward. Just try to understand the fundamentals. The way it works for SQS, that's the way it's going to work for all other interface endpoints as well. The same thing, no problem. So we've attached the SQS full access to the policy. So this guy has to the role. So this guy has S3 access and SQS access. But what we are trying to do today is just SQS. So now let's check our endpoint if it has been created. It always takes a while. Yeah, I think that's very fast. So you can see that our SQS is available now. So if I go to ENI, let me go to ENI. If I go to ENI now, I'm going to see an ENI for my SQS.
Okay. The same VPC, the same block of
Exactly.
IP now. Oh,
Exactly.
yeah, same subnets. Okay.
So you can see that this guy is 6 now. So if you check the last one here, VPC, you will see. So this is it. I think the first one is
okay,
it's 2.46.
46.
VPC endpoint. This is it. I think this one was for the Instance Connect, and this one is the VPC endpoint. So we can just this is the event. So let's click on it. You see this for SQS. If you click on it, VPC Instance Endpoint in use, you can see the VPC, you can see the subnet. So this guy is going to create an ENI. So if you go to going to create an ENI, let's come to this endpoint. This is the endpoint. You can see that the ID here is equals to the ID here, C74. If you come here as well, what's the ID? Can you see? C74 VPC endpoint interface. You can see that the ID here is equals to the ID here, backend SQS service. So this is the interface endpoint that just created. You can see this is the VPC
I have a question.
endpoint. Okay, what's your question?
And why is it coming up as a VPC endpoint?
I didn't get the question very well. Can you come?
What I think I was asking why it's coming up as VPC endpoint. We know we created an interface endpoint for that service we want to consume.
Yes. So
Okay.
it's an, I told you all of them are endpoints, but breaking them down, we have interface endpoint and gateway endpoint. So this is the SQS. You can see that the endpoint type is interface endpoint. I get it.
Yeah.
So this is an interface endpoint, but on this this is the ID. If you check this ID, if we come to the network interface here, it's just going to call it an endpoint interface. This is the ID. You can see that this is the ID, and it called it VPC endpoints because the ENI is not a generated ENI from a server. It's been attached. It's been created through an endpoint.
Okay.
I get it. So it's not like it's an ENI that is attached to a server. It's an endpoint. That's why this the interface type here is called VPC endpoint. So now we've created this thing. So now let's run our command again. Can you see? My command message has been done. So you can see that I have a message that okay, I have a response now, which means that I can connect to my SQS service. So let me go to my SQS and see something. So this is my SQS demo queue, and let's send and receive message. Let's pull for message. You can pull for message. This is the message I just sent now. Body, hello, my name is Sumaima. You can see that we get the message. So we can pull message and push message. Assuming we ask this guy as a subscriber, we can also add him as a subscriber, and it's going to get that topic as well. So this is just to show how interface endpoint works. I can try it again. So you can see that everything I did here, I don't need a public IP or any or internet to do all I'm doing. So that's why some company, they don't even need internet access for their VPC or the way they structure their applications work. Just need communication from one AWS services to another. So with that scenario, they'll be able to cut costs and do a lot of things. Welcome to AWS Cloud Series. So if I send it now, so this is just one of the examples, one of the advantage of using interface endpoint. So if you want to send a mail as well, if your company has like a simple email service that has a lot of subscribers, you can just send a message from them directly from an EC2 instance and send it across to all of them. Or maybe when an application get an update, or when the customer click subscribe or something, the server will automatically at the back end send an email and all of that. So all these things are interconnected together. So instead of now trying to add an elastic IP costs a lot of money. One of the things that costs a lot of money in AWS is elastic IP. So let me pull and let me pull for new message. Pull for message. So this is my second message. Again, I sent this one just now. Welcome to AWS Cloud Series. So this is just an example, an interesting example of how interface endpoint works. So you can see that I was able to log into this server, number one, privately, and I was able to even communicate to SQS. So this is going to be the endpoint, the endpoint of our today's session, like the interface endpoint. So at your own time, and go over it. You can just try to lab it to see how it works. You can even try to do it with other AWS services as well, so that at least you would maybe you're in an interview or someone asks you how does interface endpoint work, you'll be able to give them and be confident to explain, because it's something you understand end to end and it's something you can relate with. So thank you. Thank you everyone for your time. So is there any question before we move to this part 2 of today's class?
So what if the EC2 and SQS are on a different subnet?